Did you know you can easily measure inductance using an Arduino? Let's get started right now. In this video, we are going to build a DIY LCR meter. To be exact, we will build a circuit that measures the inductance of an inductor. The materials for this circuit are an Arduino, capacitors, resistors, inductors, and an LM311 comparator. The core components of this project are the capacitor, inductor, and the LM311 comparator. Before looking at the circuit, we need to understand resonant frequency. The formula for calculating resonant frequency is as follows. L stands for inductance, and C stands for capacitance. This is a standard LC circuit. Current from the capacitor is passed to the inductor. The current passing through the inductor goes back into the capacitor. The speed at which these two exchange current without energy loss is the resonant frequency. We use this LC tank to generate the resonant frequency. I plan to upload a detailed video about resonant frequency, so please subscribe to the channel. So, how can we use this to measure inductance? First, here is the circuit we are using today. Near the LM311 IC, I have placed an inductor, a resistor, and a capacitor. Let's assume L1 is the reference inductor and the C1 is the reference capacitor. I used the 100 microhenry inductor for L1 and a 1 micro nanofarad film capacitor for C1. Plugging this into the formula, we get a resonant frequency of about 500 kHz. This is the 0 point of this circuit. Also, instead of connecting the other side of the capacitor to ground, I connected it to pin 2. This uses a virtual ground, allowing the signal to oscillate around 2.5 voltage. I used voltage divider resistors to input 2.5 volt to pin 2 and added a capacitor to stabilize the voltage. I connected the output of the LM311 to digital 5 on the Arduino so the Arduino can read the frequency. So where does the inductor we want to measure go? It connects right here. Looking at the formula again, it's expressed like this. The resonant frequency changes according to the inductance of the target inductor. The Arduino reads this changed resonant frequency, compares it with the reference frequency, and calculates how much inductance has been added. This is the core concept of this circuit. We added a few buttons. I added main control buttons and a button to select between the primary and secondary sides. The detailed circuit diagram is on my blog, and I added an OLED to improve readability. Here are the Arduino pin settings. I used an Arduino Uno, and there is also an Arduino Pro Mini, which is the same version. Now, let's look at the finished products together. Actually, it's not completely finished. I need to fix an unstable frequency jitter and reach how to get accurate values. If you want to see this device evolve, please subscribe to the channel. For the next video, I will make a video about resonant frequency. Thank you for watching and don't forget to subscribe and like. Thank you for watching.